excuse yourselves when that time comes and quietly. But you are still taking your notes, even though you are going to be dismissed shortly. We are doing now surface area, continuing that, but specifically, instead of prisms, which is what we did yesterday with cylinders and such, we are doing cones. So the easiest cone to do actually is a cone itself, and I'm just going to give you the formula for it, and we'll discuss it later about where it comes from. So we are doing surface area of cones. Now, when you think of a cone, hopefully you think of this. Okay, this is a cone, this dunce hat right here. No, this ice cream cone. And also, though, anything that's a pyramid is also going to be a cone. So a pyramid is a special kind of cone. Both of these will classify as cones, but this one, both of them, well, what is the definition of a cone? Well, it starts at the bottom and the shape stacks upon itself, but gets gradually smaller until it gets to a point. And that's what a cone is. And if we unwrap these, we would see that this cone, when I unwrap it, would be this shape with a little circle right here. And if I unwrap this square pyramid, what I would see is a square and then 4 triangles around it. So to do surface area of a pyramid, that's going to be pretty simple. I'm going to find the area of the square and each of the triangles and add them all together. For the surface area of a cylinder, however, I'm going to need a special formula for that because we see that this is circular. It's not quite a triangle here, right? It's a little bit curved. The formula for this comes through a little trick that we'll discuss later, but I'm not going to put it in the notes right now just so that everyone gets this written down, at least initially. So the surface area of a cone is going to equal, well, first of all, pi r L. I'll give you what L is in a moment. Plus pi r squared. Okay, so what is this? Well, L is actually the only time you'll ever use what's called a slant height. Okay, this is the exception. Usually, in every single other case that we talk about, heights and bases are perpendicular. In the case of a cone, we're going to actually use the slanted height. R is the radius. So, if we have a cone, we'll have something like this. And maybe I'll give you this. And maybe I'll give you this. Okay? Notice that this would be slanted. So if I were to draw this center down and form a right triangle, I'm actually using the hypotenuse of that triangle for my slant height. So the surface area of a cone. We're just going to use this formula. You're going to need to memorize it. We'll write it every time that we use it. Pi RL plus pi r squared. Okay, pi. We'll just leave pi on it. So pi. R is what? 3. And my slant height is 8. Plus r squared is going to be 9. And then we have 9 pi. So then we have 24 pi plus 9 pi, which is 33 pi. And that's going to be centimeters squared. And that's the surface area. So that's, as long as you can memorize this formula, that's going to be fairly simple to do. All right, let's do one that's a little bit trickier, however. Do we got this down? Did anyone not follow how I did that surface area? Okay. Then let's see if I have a cone like this. So there's my cone. Notice this time, I don't have what? I don't have the slant height.
You can find it though.
Yes, I can find it. So let's talk about how we can find it. Who has an idea? How can we find it?
The triangle.
Okay, I'm going to make a right triangle. So when I make this right triangle, this is 8. What's going to be this?
6.
6. And what do I use in order to get this? Pythag. Okay, so I'm going to have 8 squared plus 6 squared equals my slant height squared.
Answer's 10.
And yes, in the end, I will get 10. All right, so now I'm ready to use my surface area formula. So I write it down. Surface area of a cone is pi r L plus pi r squared. R is 6, L is 10. R is 6, so I'm going to have 36 pi right there. So I get 60 plus 36, which is
96.
96 pi centimeters squared. Now that's the exact answer. If I wanted an estimate, I would put in 3.14 for pi. Okay, any questions on how to find the surface area of a cone? Okay, I just want to mention this so that everyone is on the same page as far as homework. So this will apply for today. Your homework is page 713, numbers 9 to 14 all, and numbers 16 to 21 all. Remember, honors, your honors project is what your homework is. So there's not much that you can be doing on it yet. Okay, some of it you can do. If you remember your volume formulas from before, then of course you could be working on those. All right, so once again, that is your homework for tonight. Oh, and apparently I took off some. 26 to 28. Nah, we don't have to do that. Okay. All right. Let's do a hard pyramid. So now we're going to do a pyramid. Now we don't have a special formula for the pyramid. I mean, I suppose we could come up with one. But let's say I have a pyramid with a hexagon base. I'm going to start that over.
Can we not do a hexagon base?
We are going to do a hexagon base, but I want it to actually look like a hexagon. Okay, just don't you worry about it. All right, and I'm going to have it tilted some just so that we can see. So there will be, let's see, which sides can I see? I can see this side, I can see this side, I can see this side, I can see this side. Okay, and then hopefully you see that I do not see these two hidden sides. Now if I unfold this, do you see the pyramid there hopefully?
Yes.
Okay, so if I unfold this, you would see 6 identical triangles, right?
Mm-hmm.
And I would have 1 hexagon.
Mm-hmm.
Now, I'm going to give you, let's see, what do I want to give you here? I'm going to give you the height of this thing. Now, let's say the height of this thing is 20.
That's mighty nice.
Okay? And I'm going to give you that this side is 8.
Oh, we forgot triangles.
Okay? So we have a lot of different things that we're going to have to do in order to find the surface area of this. Let's deal with getting the triangles first. You guys on board?
Yeah.
Now, if I take one of these triangles and I just pull it out, I'm going to have an isosceles triangle. And I'm going to have an isosceles triangle, and this length here would be 8. But in order to find the area of this, I'm going to need the height of this triangle. 20. But if I, listen, if I draw this height right here, it is not 20. Okay? It is slanted. So hopefully you would see in here another triangle, which is a right triangle. And this slanted side is the side that I need. This is 20. And I'm going to need to know what this is. Well, in order to find that, so this is really tricky here. I'm going to wait for all those who are exiting to successfully exit. Goodbye. Good luck in life. Okay. All right. What is this right here that I'm hovering my pen over?
Radius.
That is not a radius.
So Papa.
It is the apothem. Okay. Okay, we need the apothem. We're going to need the apothem in order to find this length right here, because that's the hypotenuse of that right triangle. Are you seeing what I'm talking about?
Mm-hmm.
Okay, so it's very hard to visualize. So we have a lot of steps here. So let's get the apothem. Well, how do I get the apothem? Well, all the things from the previous chapter are going to apply. So let's start with the hexagon then. To get the hexagon, I'm going to need the apothem. So let's draw this hexagon out. We have a side 8 here, and here's my apothem.
Oh, we can do that one pretty easily.
Yeah. So we have this right triangle here, so I'm going to need this angle. What's that angle? 360 divided by 12. In the end, because I have 6 triangles, and then I slice them in halves to get the right triangles. So how many degrees?
30.
30 degrees inside of there. So I have 30 degrees inside of there. I need the apothem. Now this length right here is 4. So I'm going to get the apothem. So tangent of
30.
equals
4 over 8.
4 over a.
8.
Not
8.
Not 8. So I cross multiply.
4 divided by 10, 30. Gonna get you 6.928.
And a is what?
6.928.
6.928.
Easy.
Okay. And then the perimeter is 8 times 6, so 48. So the hexagon is going to be AP divided by 2. So area is going to be this 6.928 times my perimeter, 48, all divided by
2.
2. Okay, I'm going to erase this just so I have some room. Okay, so what did we get for the area of the hexagon?
166.272.
One what?
Confirmed.
166.272.
Okay, good. So that's the area of our polygon.
Yes.
Somewhere. Yep. Daniel's got you. Okay, so we already found our apothem. Let's remember, what was our apothem? 6.928. So that's our apothem. We're going to need that in order to use Pythagorean's theorem to find our slant height for our triangle there. All right, so let's do that. So now we have our base. Now we're going to need our triangle. So we are going to use Pythagorean's theorem. So 20 squared plus 6.928 squared is going to equal our slant height squared. So we get 400 plus whatever 6.928 squared is.
47.9.
Okay, you started talking while I was still talking, so say again.
47.9.
Keep some more decimal places.
97.
997.
Yeah, 997.
997 equals L squared. Then what is L to the nearest 1,000?
21.166.
Uh-oh. Uh-oh.
Well, make sure to like
Oh,
and
my thing
subscribe.
died. Okay. That's fine. 21 point what?
166.
Oh, it died again.
Well, make sure to like and subscribe. We'll see you guys next time. Peace.
Hold on. This is why you charge your thing before you start.
You gotta make sure you add like an enter, like a do do do. Yeah, I'll do it for you. Do 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 do
There we go. Now that should help us out.
I think they're just laughing at us.
Okay, there we go. So 21 point what?
166.
166. So that's our slant height. That is this right here. Okay, that's in the triangle. So that's the height of the triangle is 21.166. So now we can find the area of one of those triangles. What's the area of a triangle?
Base times height divided by 2.
Base times height divided by 2. So 8 times 21.166 divided by 2. So the area of the triangle is?
84.664. Almost, how many triangles are 6? Yeah.
So times 6, because there's 6 of them.
507.984.
Confirm.
And then plus 166.272.
So we add the base to the 6 triangles.
Total surface area is 674.256.
600 what?
74.256.
Alright, so we'll keep that. Centimeters squared. We'll say that was centimeters. Boy, that was really sloppy, right? A lot of stuff there. Let's try one more. A little bit less intense. We'll do a pentagon.
That's one side. Less intense.
Okay, so one side less. So,
Well, the top's not like that. Top's that. Right. Straight line.
Draw a
okay,
trapezoid.
so there's our pentagon. Okay, guys,
Trapezoid with a triangle on top.
you ready? So here's our pentagon. And we will have a... Boy, I'm really having a hard time getting a regular pentagon. It's really not cooperating. Alright, there it is. Alright, so there's our pentagon. Alright, so we have a pentagon, and we'll have, here's our top of our pentagon.
And that's bigger.
Okay, and we can't see that side. Okay, yeah, you might want to get to a different spot.
Hey, why don't you sit here? Okay, so sit right here.
Okay, I am good. I'll wait for you guys to quiet down. Okay, let's say I give you this. Let's say that is 8, and I'll give you this side is 4. Now we have to be very careful when I say this. I mean if I take one of those faces of the triangle. So this is where you're going to want to be able to definitely do a net drawing. So you understand, I have these triangles right here. Okay, I have a nice little star. And what I've given you is this. That is 8. Okay? And I've given you, this is 4. Okay? Well, let's start with the pentagon. So I'm going to get the area of the pentagon first, which is the last chapter. Area of a polygon is the apothem times the perimeter divided by 2. So I have the perimeter, 4 times
5, 20.
So 20. So I have my 20. And now I need the apothem. So I'm going to find the apothem of this. So that's here, using my right triangle.
36.
So let's draw that triangle up here. I have 2 right here, because it's going to be half of that length. And here's my apothem. I'm going to need the angle in here to get that. It's going to be 360 divided by how much?
10.
10. Wake up, Coleman. So we divide that by 10, and we get 36 degrees in here. Alright, so how do I get the apothem?
Now you do
On
10.
So tangent of 36 degrees equals?
2 over A.
So A is going to equal 2 divided by tan 36. And just for speed, let's get it to the nearest tenth.
2.8.
2.8?
Yes.
Alright, so what's the area of my base?
28.
28
Yes.
units squared. Okay, so that gives me this. I have that. Now I need one of these triangles. And how many of these triangles do I have? 5. So I'm going to get area of a triangle is base times height divided by 2. I do not have the height of this triangle. It's right here, right?
Split it in the right direction.
So it's a right triangle with a hypotenuse of 8. And this is 2 right here. So I need this length right here. I can use Pythagorean's theorem. So 2 squared plus my slant height
7.7.
equals 8 squared. And I'm hearing that L is 7.7.
Yep.
So notice we use L to mean slanted height. Okay, so area of my triangle is base, which is 4 times my height, which is this 7.7
Divided by 2.
divided by 2. So the area of one of the triangles is,
15.4.
and then we'll multiply that by 5 and get,
77.
so we'll add the 77
5.
to the 28 and get,
105.
all right, definition. Lateral surface area, because we didn't formalize this last year. Lateral. This is going to be the surface area without the base. So when we are talking about a pyramid, say I have a square pyramid here. If I want the lateral surface area that I do not want to include that square, okay? It would be all the triangles without the square. When might I want that? Well, if I'm painting a house, I'm not going to paint the floor, right? I'm going to paint only the walls, so that would be lateral surface area. Let's see here. Do we need another example of pyramids? No, we didn't do the easy pyramids. Let's do one more. Let's do a square pyramid. Let me think. What information do I want to give you? I will give you this. Let's say that's 5. And I'll give you this. Let's say that's 6.
That's real easy, man.
And I'm going to ask you for the surface area of the pyramid.
Laterally.
And I'm going to ask you, well, how tall is this pyramid? All right, so it's not 5 tall, okay? Because that's slanted,
That's
right?
the height of the triangle.
Okay, that's the height of this triangle right here.
The area
So-
of one of the triangles is 15, by the way.
Yes. Okay, so if I unfold it, I would get this shape. That's my net drawing. And this is 6. And this right here is 5. Alright, so the area of a triangle is base times height divided by 2. My base is 6. My height is 5 divided by 2. So one triangle is 15, but times 4 of them for 60 units squared for all 4 triangles. You with me?
Area of the square.
And then I need the area of the square. The area of the square is base times height. Well, that's 6 times 6,
36.
36. So the surface area is going to be 96 units squared. Okay, well, how tall is it? Well, if I finish drawing this, I see a right triangle in here. Do you see what I'm talking about? And this is going to be 5. Now, it's hard to see, but this would also be 3. Okay, so I can use Pythagorean's theorem and get a height of 4. 4.
Oh, so that I thought that thing was. So that thing's going to the center of the thing, then, not
Yeah,
the actual
yeah.
side.
Yeah, it would be like
It
this.
looks weird.
Yeah, I should have drawn it right there. Okay, so yeah, it's hard to draw these in 2 dimensions, so that's certainly the case. All right, we are done with note.